Good morning, everyone. Thanks so much for joining us for this morning's webinar, The Efficient Vineyard, Improving the Bottom Line for Growers. My name is Jen Cooper, and I'm the Membership and Events Manager at the New York Wine and Grape Foundation. Before we get started, we wanted to take a moment to thank the National Grape Cooperative for bringing you today's program. We truly appreciate their support. I'd like to give a warm welcome to both our New York winery and grower community, as well as our presenters today, Dr. Terry Bates and Nick Gunner. Dr. Terry Bates is a Senior Research Associate and the Director of the Cornell Lake Erie Research Extension Laboratory. The program focuses on viticulture with an integrated systems approach to vine productivity, fruit quality, and farm profitability. Research interests and contributions include vine mineral nutrition and root biology to control vegetative growth, mechanized vineyard management for fruit quality and labor reduction, and precision viticulture to increase production efficiency. Terry was the lead PI on the Efficient Vineyard Project. Nick Gunner is the CEO, Chief Platform Engineer, and Lead Designer for Orbitist, a company he started in 2015 that specializes in cloud-based mapping software designed for agricultural regional destination marketing organizations. Nick is the principal developer who has worked with Terry to create the MyEfficientVineyard software we'll be highlighting today. Funded through the USDA-NIFA-Specialty Crop Research Initiative, the Efficient Vineyard Project is a national effort to advance the use of precision viticulture in wine, juice, and table grape production. Disciplines of engineering, precision agriculture, viticulture, and economics come together to measure vineyard soil, canopy, and crop characteristics, model spatial data for viticulture information, and manage vineyard crop load through variable rate machine applications. We're truly excited to be welcoming Terry and Nick today. We encourage you to ask questions through the Q&A feature at the bottom of your screen and engage with each other in conversation through the chat feature on the right-hand sidebar of your screen. And with that, Terry and Nick, thank you again for being with us all today, and I hand it over to you.
Great, thanks, Jen. I just want to take a second to thank the Wine and Grape Foundation for having us here today. To Sam and Jen and Valerie, and of course, Dana Alexander, who I like to tease a lot because we grew up together. And also National Grape, Rob Smith, for kind of getting this going for us to give the talk today. And I just want to say it's probably something that I consider very important and probably little recognized is the good relationship between Cornell University, the Wine and Grape Foundation, and the industry. It's really the foundation of getting the work done here in New York. I mean, I've been here over 20 years and been very well supported by the Wine and Grape Foundation and the industry. And the only reason we are able to bring in USDA dollars for a large national project and bring those resources back to New York is that we have that foundational backing by the industry to help set priorities and fund research that we do. So I just want to start by saying thank you. And then I'll move on to our presentation. And I hope you can see that. Nick, give me a nod. Yes. All right. So yeah, I'm Terry Bates. I am director of the Cornell Lake Erie Research and Extension Lab, and was the project lead on the USDA project called the Efficient Vineyard Project, which has now officially ended, and we've moved into other new projects, which I'll explain about in a little bit. So I'm going to talk, this is how it's going to go today. I'm going to talk fast and furious about the Efficient Vineyard Project. And then Nick is going to slow you down. He's got a very calming voice and is going to give you a little tutorial on a thing called MyEfficientVineyard, which is web-based software for growers to upload, visualize, process spatial data in their own vineyards. So I'm going to kind of give you the overview, big, high level picture, probably give you more information than you need to know. So two things I want you to know from this slide is all the information that we're going to talk about today can be found on efficientvineyard.com. So there are articles, there are tutorials, you can access the software that we've developed all on efficientvineyard.com. The second thing I want you to know is that the project is all about measure, model, and manage spatial data in your vineyard. So the engineers that we worked with, they call it sense, plan, and act. Use a sensor, an electronic sensor in the vineyard to collect spatial data, and then process that data to make the most sense out of it, to get the most useful information out of it, and then use that spatial data to do variable rate management in the vineyard. Our precision ag friends say data, information, and decisions, but we're all talking the same thing. And I'll get on my soapbox for just 1 second before I get into some of the juicy details, because I get this question all the time. You've been working on precision viticulture for a while now. Does it work? And to me, it's about, the measure, model, manage is the technology, it's the process, it's the tool. It's kind of like saying, does a hammer work? Well, it really has to do with who's using the hammer and what they're using it for. I think precision viticulture does work. As a researcher, I hate to work in absolutes, but somebody says, hey, does it work? Yeah, absolutely it works. But you can't divorce the viticulture from the technology in the situation. So you have to use the technology to answer a viticulture question and move forward. So it's all about who's using the tool and what they're using it for whether or not it will work. Okay, so back to measure, model, manage. I'm gonna go a little out of sequence here. I'm going to talk about this kind of the state of where we are with measuring things in vineyards, what sensors we're using, what sensors we're currently developing. And then I'll give an example on the managed side. So how we take spatial data and we use it for variable rate mechanized management in the vineyard, although variable management doesn't need to be mechanized. It can be done by a person, not necessarily a machine in the vineyard. And then the final part of the talk is going to be about the middle part. And that's where Nick's going to come in and talk about the MyEV. So it's bridging that gap between collecting spatial data in the vineyard and using it for management. MyEV is that tool that growers can use and access to visualize and process that spatial data in vineyards. Okay, so where we are with the sensing stuff. We've done a lot of work with sensors. We've done a lot of work validating sensors in the vineyard. So most sensors are they're electronic gadgets that you use in the field, like the soil sensor is an electromagnetic sensor. The canopy sensor is a reflectance sensor. The crop imaging is a 3D image modeler. The harvest yield monitor is an actual physical sensor on the machine that's looking at the impact of grapes against that plate, turning that physical signal into an electric signal that's recorded by data loggers, right? So we have all different kinds of sensors that give you an electronic output, and that doesn't necessarily mean anything in the vineyard to you viticulturally. Like, you want to know what the soil is like, you want to know what your pruning weight is or your canopy fill, you want to know what your crop size is. So how do we translate those electronic sensors and that electronic data into useful viticulture information? So in terms of soil, we use a dual EM soil sensor, which gives us a spatial pattern of the soil. So it's essentially telling us about clay and clay content, and it gives us that spatial map, which we can sample against. Our crop circle canopy reflectance sensors gives us NDVI, and actually in this case, it gives us 3 different wave bands. We can calculate things other than NDVI, which is normalized difference vegetative index. What we really use it for is to say, is there photosynthetically active tissue that it's detecting in the vineyard? We use it as a side, we place it up against the vineyard wall as a side facing sensor, and we measure that photosynthetically active tissue. In some ways it can measure leaf health, but we don't use it that way. We just say, is there green tissue there or not? In early season, say when the shoots are 3 to 5 inches in growth, we use it to look at spatial shoot density maps. Scans around bloom relate best with yield. So we'll use that spatial NDVI map at bloom to do our crop estimation work. And then at around veraison time, those NDVI maps correlate well with vine size. So we'll use that in our crop load calculations. The next one down for crop, we did work with Carnegie Mellon University on developing an image sensor. So it's a stereo image sensor. And the real science behind is, so it takes images in the vineyard, it stitches them together. Then the engineers use these algorithms to identify things in the pictures and then count it. And then they give us that geo-referenced data. And we use that in the vineyard to do visible berry count and color development in grapes. We've been working with Oxbow International on a yield monitor. So again, that's their yield tracker system. And then Andy Joy and Dan Sprague Jr. at the lab in Portland at Clairol, they've developed a mechanism to subsample fruit as it goes across the harvester belt and turn it into free run juice, which then we run over a refractometer, and then that gets logged into a data logger. So we can map yield and Brix on the fly at harvest. The two sensors in blue, the vine nutrients and the food metrics, I'm going to talk about next, and then Nick is going to talk about the data collector. So the point I'm trying to make in this kind of complex slide is the list of things that we can spatially measure in the vineyard and start mapping and integrating is getting longer and longer. There's very active areas of research across the country looking at sensor development, new sensors for disease detection, nutrients in the vineyard, fruit quality. And as those new sensors come online, we're going to want to put them into our data pipeline in the MyEfficientVineyard software. Okay, so the first one I want to talk about is the nutrient sensor. So this is work that we're doing in collaboration with the Rochester Institute of Technology and also with Justine Vandenheuvel at Cornell University. Rob Chancia here is a postdoc on the project doing a majority of the sensing work. So we have drones that come out to our vineyard. We do this at Veraison and at Bloom. So we did it at Veraison last year. We did it at Bloom and Veraison this year. And there are three, so very expensive, pretty high-tech sensors that are on these drones that are scanning the vineyard at a variety of wavelengths. We'll just put it to you that way. And what we've done is we've set up a vineyard at the lab that has blocks with different nutrient deficiencies. So just based on, the vineyard work we've done over the years, we kind of know how to make the vine sick. And we try to establish these nutrient deficiencies, and they fly their drones over that vineyard. They scan the vineyard at all these different wavelengths and try to identify wavelengths that are showing us the difference in vine nutrient status. And so we validate that in the field by taking individual vines and collecting leaves and petioles, again, at Bloom and Veraison, when they do their scans. And then we do some machine learning. And it's not going to get into the whole science of machine learning beyond the level of this talk, but to identify wavelengths that are telling us what the nutrient status of those vines are. And the cool thing is now they can, once we're satisfied with that model, they can fly it over a commercial vineyard and give us a nutrient map, or at least the vine nutrient status of that vineyard, which we then can layer with our other data and use it in our management decisions. And in this case, we would use it for variable rate fertilizer application. Another thing we're working on just this year. So this stuff is kind of hot off the presses. We've just been working on this in the last couple of weeks. Is a fruit quality sensor. So this is something that Donnell Brown at NGRA got us hooked up with Felix Instruments. A guy named Galen George sent us their produce quality meter. And it's also a spectral, it's scanning in the visible to near infrared range. And what we do is we take fruit of different maturity levels, we stick it on that little window, we hit the button, it scans it, collects all that data. Then we take those 3 berries off, we squeeze them, and we get the actual Brix reading off of that. And we'll also be doing this for titratable acidity, pH, and color as we continue to build these models. So we take that spectral information. So again, very similar to what we're doing with the nutrient scans, is it's scanning that fruit at a bunch of different wavelengths. It's looking at what wavelengths are showing the difference in relation to the different maturity of the fruit. So in this case, in the difference in the Brix in the fruit. And we start to build models So based on the spectral signature and the actual bricks of the fruit, we build a model. When we're happy with what the model says, we can then take the machine out into the vineyard, just put it up against some fruit, hit the button, it tells us what the bricks are. And the goal or the hope is down the road that we would run like 4 models simultaneously and give us bricks, TA, pH, and color in the vineyard. So this particular unit has a GPS receiver right in the unit. So as it's collecting that data, it's also collecting the GPS location in the vineyard. So you would be able to spatially map the data you were collecting with this. The last sensor, and probably the best sensor, is you. We all go out in the vineyard as vineyard managers and we make spatial observations about the vines. Sometimes we record it, sometimes we don't. In this case, I'm out in the vineyard this spring and we were assessing the frost damage in a particular vineyard. And we wanted to be able to collect that spatial data. And so, if you weren't going to invest in sensors, expensive sensors, or the sensor you want's not quite developed yet, could you, using yourself as a sensor, go out and map that spatial data? And so Nick has developed this thing called a data collector in the MyEfficientVineyard software, where you can set it up to collect whatever you want. And as you walk through your vineyard with your cell phone, in this case, what I'm showing is we were rating vine size last fall. And then I just went out and walked that vineyard, collected that information, and was able to spatially map it in the vineyard. So where does my mind go with this? So I put this up here because Tim Martinson, as many of you know, does his Verasion to Harvest newsletter, where we are collecting fruit in the vineyard and across the state and giving numbers about different varieties. But Tim is the one that always tells me that it's not always just about the numbers. At this time of year, I know a lot of winemakers are out in the vineyard collecting that fruit, tasting it, and deciding on, how that fruit is maturing, how does it taste, and when the harvest date is going to be. And where I immediately go with this technology is, oh, what if I had a fruit quality meter, and then I had, I measured those 3 fruit that are on the window, and then I did my taste test in the vineyard and used the data collector app to record how the flavor is developing, either notes or some kind of rating about the fruit, and now try to be able to marry, like in any given season or with a given variety, start to marry your numbers with what the winemaker is tasting and be able to do a better job, not only spatially mapping fruit development in the vineyard, but also determining when to harvest that fruit. Okay, so that's where we are with the sensing. Next, I want to talk about the manage part. So all the way to the right, where we're taking machines in the vineyard, we use that data, we make the machine variable rate to give us what we want in the vineyard. So example, and there's a video about this on the MyEV site, the MyEfficientVineyard site under the Vit blogs. There's a video about doing crop estimation and thinning. So in Concord, we tend to leave more buds than we need to set a bigger crop, and then we assess the season and then decide if we need to thin some fruit off or not. So that's exactly what we did this year because we set a pretty big crop. So I go out in the vineyard, I use my NDVI sensor, I get a map of that vineyard, right? I get a relative electronic signal from that reflectance sensor about this vineyard. And I have, I separated the data into 3 zones, the red, green, and blue. And I went out and validated that with some observations. And I know in the red zone, I have small vines, or like 1 pound vines. And I have medium-sized vines, and I have big vines. And I know from my Concord crop load model that, I'm going to want to hang different amounts of fruit on those vines. The sick vines need to have less fruit on it if I want to maintain vine balance and the development of fruit maturity at harvest. So what we do is we do a random stratified sampling in that vineyard, meaning I need to take samples from the red, the green, and the blue. Within the red, within the green, within the blue, I take random samples so that I try to get a better sample of that vineyard. And then I do my crop estimation. For those of you who don't know, what we do in Concord is we take like each one of those dots, we lay out a rope that's 1% of an acre, we clean pick that 1%, we weigh the fruit, at 30 days after bloom, and the fruit's about 50% of its final weight, we double the weight of the fruit, and that's what our harvest weight is going to be. So in this case, we estimated that from our samples that we had 8 tons per acre in the red, 10 tons per acre in the green, and 12 tons per acre in the blue. And from all the bazillion of years of Concord pruning crop load research that we've been doing ever since the days of Nelson Chalice, we know that the 3-pound vines can hang a bigger crop and remain balanced. The medium-sized vines, we needed to take some off, and the small vines that were really stressed, we needed to take off even more. So I wanted to thin fruit from that vineyard, but I wanted to do it differentially. How do we do that? In this case, we set up a row in a vineyard, sacrifice the row, and as we go down the row, we start shaking those vines at different rates. So what we're doing is we're using the field computer that's in the cab to control the hydraulic valve that's in the shaker head. And we measure that in how many gallons per acre, how much hydraulic flow that we have. So as we increase the gallons per acre in our shaker head, the shaker heads move faster, and we took off X amount of fruit, 20, 30, 50, 70% of the fruit. And we record that, how much fruit that we took off in those different rates. So we get a rate response. And I know, for example, if I want to take off 40% of the fruit, like in the red zone, I need to set up my machine at 450 gallons per acre. Using this ag leader hardware and software, I dial that into my prescription map, and then our guys just drive the vineyard and the shaker head speeds change automatically. So that's how we do like automated variable rate fruit thinning in the vineyard to get fine balance. Okay, so that gives you kind of state of the art of where we are with the measuring, and it gives you kind of where we are state of the art with the management. We've done this with variable rate shoot thinning in the spring, variable rate fruit thinning at mid-season, variable rate fertilizer applications. And again, if you don't manage your vineyard by machines and you want to do variable rate stuff, you could take that prescription map. That is, if you're using MyEV and it's on your phone, you can have your farm workers have that on their phone as well. So when they're going through the vineyard, say at pruning time, if they know they're in the red zone, you tell them, I want you to leave 40 buds. And if you're in the green zone, leave 60 buds. And if you're in the blue zone, leave 80 buds. So that's another way of getting at the variable rate management using spatial data. Okay. So now to the middle section, which is the development of the MyEV tool. So this is a completely selfish reason why this whole thing got started, is that I needed a simple, easy way to process spatial data for myself to do the research that we were doing. And Nick was working on the MyEfficientVineyard project, basically doing web development. And as I got to know Nick and I got to know his talents as a software developer, we started having conversations about, oh, how would I actually process some of this data? I'm using ArcGIS and QGIS and other spatial data management software. And I'm like, man, growers are going to have a really hard time learning this software. I mean, something like ArcGIS is the top of the line software. It has lots of features, lots of functions, and it can be not as easy to use. And it's also not agricultural specific. So we needed something that would pare down the activities we wanted to do and make the workflow easier for growers so that they could approach spatial data as well. So we started developing the MyEV tool. And so here's Nick. So the whole idea of the spatial data pipeline, again, is it's your farm. So you want to establish your farm blocks, import spatial data to those blocks, be able to visualize, process, be able to look at that raw data and make decisions on it, translate that data, again, electric signal into, say, pruning weight. You want to be able to translate that into something that you understand. And then we get into more, so that was like the core. right? I want you to upload, visualize, process spatial data so you can get a map and then you can do something with it. We're getting into more advanced things that I don't think we're going to talk about today in terms of data interpolation and multi-layer integration. But again, this is kind of an introduction to the software. And if you get in there and you get using it, you'll probably get to that point where I want more and I want to do more with it. And you'll be getting into the more advanced things. So what you do is you go again to the efficientvineyard.com. Where we house this. Under the Vit blog section again is there are tutorials and videos on how to use the MyEV software and some of the other research that we're doing. You go to the big red dot or button in the corner called the MyEV tool, and you click on that. It'll bring you to a jump screen where you can establish a free account. And then you can get in and you can start building your farm. So you go in, you can draw blocks, you could add information to those blocks. This happens to be the Cornell Lake Area Research and Extension Lab. And some of the vineyard blocks that we have there. From that, you can upload spatial data. So Nick has gone through, and this is no easy task. He has gone through all the sensors that we currently use. He has gone through, and they'll all come in at different formats. So he's been able to write the software code that allows direct importing of the spatial data from our different sensors into the MyEV app. Again, if you don't have sensors and you want to use the data collector tool, and I think Nick will give an example of this, there's a little clipboard in the corner. You click on that and it allows you to build your own data collector tool that you can take to the field and collect data. There's some housekeeping things like we're always running into bug fixes or people want, they start using it and they say, hey, we really want this function. This would be cool. You can provide feedback to myself and Nick, and we can try to address those needs. So you go in and you import this data, whether it's from a sensor or from your own phone app. And so when you pull in sensor data, it can often be messy just because you're collecting data on farm roads and headlands, and the sensor is sometimes giving you errors. And so there's a whole data cleanup thing that you would do in ArcGIS, and Nick has created some very simple slider tools in the software to be able to clean up that data. And then you can visualize it. You can click on data points and get values for them. So you can kind of interrogate the data a little more. And to me, the cool thing is now you can clip that data. Once you've cleaned it up, you can clip it to blocks. So if I just want to look at my Niagara block, or I just want to look at my Vignoles block, I can just look at that single block and how that data varies within the block. I think I'm going to stop here by just saying and drive home the point. You can make a high-end investment in this, use sensors in the vineyard, import that into either MyEV or other spatial software, process that data, zone it out, and do variable rate management in the vineyard. Or to get started, and I think this is where most of our growers are, to get started is something very simple. Use your phone and your own observations in the vineyard to collect spatial data and start mapping it. And then once you get your feet wet and you get comfortable with that spatial data and possibly what you can do with that data, you're just going to naturally, I think, start moving towards the more advanced options. Here's where some of the accounts, and I think this needs to be updated because I took this a while ago, but there are more and more accounts coming online. There's some examples of like people in New York using it for soil mapping. There's a outfit in California that's been using it for virus mapping in their vineyard. So again, anything that you want to collect spatially is kind of what this platform is meant to do. And okay, with that, I'm going to
Terry, could I have you go back a slide real quick?
Yep.
I just wanted to point out that map in the lower right with the red, there's there's like, I don't know about there's thousands of data points in there. Those were all collected with the collectors, workers out in the field making observations by hand. So those were very dense data sets that we're done with a cell phone.
That's awesome. Yes. So yeah, something I think I did not mention is, so the buttons up at the top, you can invite collaborators. So originally our intent was a grower goes out to the field, collects their spatial data and wants me to look at it, or wants Hans Walter Peterson and the Finger Lakes to look at their spatial data. You can invite that person through their email to view your map and be able to comment on it. And you guys can, social media, talk back and forth about your spatial data. And what that outfit was doing is they make their farm workers collaborators. So within that map, they can add data, they can see data that the farm manager puts on there. And so you can have that two-way interaction between the manager and the farm workers. So do you have a screen to share, Nick?
I think so.
Okay, I will stop sharing and you can start sharing.
Barry, before we get started real quick, a question came through from Jonathan Rodwell. What could be the range in bricks across a bunch of grapes, berry by berry?
Really, that's a fantastic question. And I was talking this, I was showing these slides to somebody the other day, and I said the same thing, that this tool, you put three berries on the window, and it's like, well, if I go to another 3 berries on that cluster, that I'm going to get a completely different reading. So it does raise the question about how do I take a sample off of that vine to be confident in the mean on that? So that's a great question. The scientific answer is we would have to pull or measure non-destructively all the berries on that cluster and look at the variation in the data. And then you could actually calculate how many samples you'd have to take to be confident of your mean. The non-scientific answer is just take a bunch of measurements. I think there's 2 ways you can use that instrument. One would be to actually spatially go through the vineyard and collect different measurements. Another way to do it would be to use other spatial data to like map the pattern in your vineyard, and then do the directed, say, 10 samples across that vineyard where you go to, or 10 locations where you go to one location and you would take a lot of readings off of that one vine and be confident of your mean in that area or a set of vines. So yeah, it can vary a lot. So it does raise the question about what's the appropriate sampling. That's a really good question.
Can you see my screen?
Yes.
Oh, okay. We good to proceed?
Yep, go for it.
Okay. So before we get started, I just wanted to point out, Terry did a great job of introducing and giving an overview of everything. So I'm just going to do a quick demo of the software to just show you how fast it is to collect a little bit of data, process a little bit of data in your web browser. If you go to efficientvineyard.com/docs, we're putting all of our video tutorials on this one page. So we've got a variety of videos. I think in total it's maybe a half an hour of content. And so in the time that we've spent on this call, you can pretty much learn everything there is to learn at a pretty deep level about how to use MyEfficientVineyard. Again, efficientvineyard.com, you can click on the MyEV tool. That's how you'd log in. It's fairly easy to create a new account if you don't have an account and set up your farm on there. Again, there's instructions for how to do that right on here. The first step is to create the blocks within your farm so that your farm looks something like this. Again, it's very easy to do. I'm going to skip over that step right now just to get right into the basic data collection. Then perhaps how to upload a data set from a sensor that you may have used on your farm, and then process some data and turn it into a format that's a little bit more useful. These screens, these interfaces are all mobile ready. So you can use Efficient Vineyard, use the My Efficient Vineyard tool on your cell phone, right in your cell phone's browser. When you go there, it will prompt you to save the web app to your phone. So you can actually save your MyEfficientVineyard app right to your phone. Again, there's instructions on the docs page for how to do all of that. That is to say, when I show you something here on a desktop, it directly applies to your phone. So you can view this farm exactly like this. It's just going to kind of crunch everything in to a nice, smaller screen size. As Terry mentioned, down here in the lower right, we have our data collector feature. When we click on this, it's going to show us any collectors that we have right now. We have one in here called broken posts. This is a very simple kind of data that you probably could get some value right away out of collecting. You're driving the tractor down a row and you notice a post that needs some work. Wouldn't it be nice to just push a button, grab your latitude and longitude and make note of that post, and then have a map of all of your posts? And so the way we created this, we just went to create new data collector. We called it broken posts. We can give it a description if we'd like to, and that description would just show up right here. And then we add fields. Fields are just, what do we want to collect about this data? In this case, I think we just put in there, and actually I can go in and edit the other one here. We just put in a severity field, and this severity field just had two options: not too bad and really bad. This could be a number value. You could do like 1 through 5, or it could be a note, a text value where you actually type in something. And I've made this field required. So long story short, you're out in the field and you're going along and you push the broken posts button. This is going to try to geolocate me right now, but I'm on my computer. If I was on my phone, the map would fly to where I am in the field and it would place a dot on that screen. But since I'm on my desktop, I'm just going to click. You can also tap on the screen to drop your point wherever you want. And then I'm going to say the severity of this post is not too bad, but it could use some help. If you hear any loud screaming going on, it's my son in the background. I think it's lunchtime or nap time or something like that. So I apologize for that. When we save these data points, it goes into the data set. So if I come back here into my datasets folder, when you create a collector, it automatically creates a new data set. That new data is going to be logged into. So if I launch this broken posts data set, you'll see that I've collected a few dots. This is not on the farm. I did these out in the forest and in a random location just to test this. But you'll see we have these points, and if I click on one, you'll see this is a not too bad post. It was updated 7 months ago. Now what I can do is look over here and we can actually start to color these data points. You can see that these 2 points are not too bad. The way we did that was we just said color setting. We want it to be a value-based color setting with categories really bad and not too bad. And it just automatically colored this. So if one of these was really bad, it would be red on the map. This would be handy. You can imagine having all of your team doing this and being able to pull up one map and see where all the really bad posts are and where all of the okay posts are. So you could start to prioritize. Again, we've used collectors for all sorts of things, as Terry mentioned, including pests, different estimates in the field, and things like that. The collectors we really like because they are a really easy way to get into data collection. You don't need to invest in anything. Everybody has a cell phone, and it's just a way for you to use your eyes and ears and your own senses to start collecting data and mapping that data in your vineyard. So if we think about the next use case, which is we already have some data, we've taken a scan, we've had someone come out maybe and take an NDVI scan, for instance. We want to be able to utilize that that data. So I have a data set. I'm going to come into my data sets drawer, come back to the root of this here, and I'm going to upload data. We'll call this full farm NDVI. And I'm going to upload. Right here in my downloads folder, I have, this is NDVI from a GeoScout sensor, and it's in the text format. We support all sorts of file formats, shape files, GeoJSON, KMZ, and we're adopting, basically our goal is to be able to adopt all of the major GIS formats so that any file you have, you should be able to throw it into MyEfficientVineyard and get a map out of it. So you can see it uploaded that file, it converted it into a standardized format that we use within the platform, and it's displayed a preview there. So I'm going to submit and save. And once this loads up, you can see it pulled up the data set, full farm NDVI. Now, this is a not very useful map. It's all yellow points. So again, we want to color this data set by something. So if I go to value-based, you're going to see all of the headers that were collected in this data set. We have course and speed and elevation. So if I click on elevation, for instance, you're going to see that on this farm, the elevation kind of starts low and it kind of goes uphill across the vineyard. This data set collected NDVI, which is the useful bit of information. So I'll click on NDVI. You're going to notice that the field looks all green. And the reason for that is that we have a lot of outliers in this data set. So if I scroll down to the bottom here and click on add a filter, and I filter by NDVI, it's going to show us the distribution of values across this whole entire data set. And so this should look like a nice bell curve here, but it doesn't, and then the reason is we have a minimum of -222 and a maximum of 103, even though NDVI values should be between 0 and 1. So we have some very out there data that we just know is bogus and we can get rid of it. So what I'm going to do is just type in 0 here in the minimum, 1 in the maximum, and then I'm going to trim. And now we have a much prettier bell curve. We still have a lot of these really low values, and you can see those low values are correlating with areas in between the blocks where we're just taking a picture of the sky basically. And so those, we know those are also bogus. So what we can do is we can start dragging this lower handle highlight the blocks, and then at some point we're going to start hitting real values that are inside of the blocks, and so that's about when we would back it off and say no, we want to include those values. So we'll back it up. It's going a little crazy right now, I think because my internet is being a little bit bogged down from talking to you all. There, so it just filtered out those rows. We're going to pull back on some high values too, just because we don't live in a perfect universe. And so now we have a little bit more of a realistic distribution, and we're already starting to see a little bit of variation on some of these blocks, some high areas, some low areas. What I want to do is focus on this railroad block here. So up at the top, I'm going to click on copy data set. And we'll just leave it copy full farm NDVI. Actually, I'll call it railroad. And what I want to do is I want to use the filters that I just applied. I want to filter all that stuff out before I copy this data set. And I want to trim this data set to a block. So that'll give me the blocks that I can choose from. And I can select multiple blocks if I choose, or I can just select one, which is the railroad block. Now, when I copy this, it's going to create me a new data set that is filtered and trimmed to just that railroad block. So I'll click on that. Here's our railroad block. It maintains the way that we visualized that data. And so now what we can do is a kind of an advanced feature where we can do what's called an interpolation on this block. I won't go into the specifics of it. Basically, that's going to smooth the data out and present us with a zoned map that's going to give us a little bit more of a useful map. We put all of our advanced features in the plugins drawer right here, and we're adding new features as we go. We have something called an Interpolator. So if I click on that, I'm going to browse to this data set that I just created, Railroad Full Farm, and I'm going to interpolate it by NDVI. So we'll run this. This is all happening on the cloud, by the way, so none of this data is on your computer. What's great about that is that we're backing it up for you. So it's up on the cloud, it's backed up. You're organizing it in folders, you're sharing it with your team in a place that isn't on somebody's hard drive somewhere. This process can take a little bit of time. Generally, a big data set is like 30 seconds, 20 or 30 seconds. Once it's finished, I can download directly to my computer that interpolated data set, or I can add it back to my MyEV account. It'll tell me when it's added back. So I'll come back to my datasets folder, and there it is, Interpolated Railroad Full Farm NDVI. And now I have to reestablish my my visualization settings because the values are in a different range. So I'm going to color it by NDVI, and you're going to start to see a much more useful, clear variation. I'm going to use a different ramp setting. I'm going to go, let's go Jenks, which is sort of going to block it out into zones, and we're going to just do 5 zones. Actually, I'm going to take this down to 3 zones. We support 3 to 10 zones. And there we are. So just this is a really quick example, a single data set. We're not joining anything. So a single file from a random piece of equipment into MyEV through a standardized process. And now we have a map. We can load this map up while we're out in the field and geolocate where we are, so we can see ourselves on this map over top of this data set. And there's a lot more that we could go into. We can download this data set. We have the original in here, GeoJSON. We can print this map. So all sorts of things like that. Terry, am I missing anything in your mind? I don't want to spend too much.
Nope, I think you're good.
I'm on a demo.
Yeah. You want to hit the plugins folder for a second?
Yes.
So just quickly, so a data joiner, just so people understand what it is, a data joiner is after your data is interpolated to a grid, like the one you have here. So say you have multiple sets of data, you interpolate them. So the software uses a fishnet grid. So anytime you pull in new data, it is going to interpolate it to the same grid. And so the data joiner, what it allows you to do is, so say if I have 5 different sensors, I've interpolated it all to the common grid. So now I can download that data set. And so in this case, our fishnet grid is roughly the spacing of our vines. So every dot is a vine, essentially. And so then you can mine through that data and say, oh, I have this kind of soil, this kind of canopy, this kind of crop, all at this one data point. Helps you make, more advanced decisions. You already went over the interpolator. The raster analysis one, it might be interesting to some of our listeners in that if you have drone or satellite imagery of your field that comes in a raster format. So that is, that is whatever. That's a raster file. It's not a point file. MyEV works, everything is works on points. So the raster analysis, well, you can import your raster imagery and then it converts it to point data. So then you can layer it with all your other data. And then the grid generator is mostly used to, in like this particular map, if you zoned it into 3 sections and you wanted to randomly sample within each of the zones, you could hit that, that grid generator and it would generate those points for you. So then either yourself or one of your farm workers could go out to those validation points and collect the data that you want. So those are a little bit more of the advanced features.
Barry, another question from Jonathan Rodwell. With NDVI in the winter, can you get vine cane mass and thus an idea of the load?
No. So NDVI is working off of wavelengths in the red and near infrared. So it's working off the reflectance of green photosynthetically active leaves. So in the winter, you don't have that. But what we do is we take that Veraison NDVI map and then we sample against that for pruning weight in the winter, because that tends to give us our best relationship. The Veraison NDVI, most of this is done in Concord. So our Veraison NDVI relates best with pruning weight. So we use that Veraison NDVI map, we zone it out, and then we do subsampling in the vineyard. So I don't have to collect pruning weight over the whole vineyard. I can just go to specific locations in the vineyard, take a few pruning weights, and then validate that map. Does that make sense?
Do we have any other questions that folks might have?
I will add to that. So just another active area of research that we're doing is with, we're still working with engineers at Carnegie Mellon. I didn't talk about this at all. So we were successful in getting another federal grant to continue our work on robotic pruning. So basically you're using the Carnegie Mellon image system. We're using it to develop a robotic pruner. And what it does is it scans. So the robot goes up to a vine in the winter, scans it, identifies the canes, identifies the locations of the buds, and then we're trying to program the robot to be able to then prune the grapevine. I have some videos of that. But in that case, it's using the image analysis to give you pruning weight. So the technology is being developed to just do that with a visual sensor.
Great. Well, I don't see any other questions that have come in, but thank you both so much for taking time out of your busy days to join us today. And again, thanks to National Grape for bringing us this program today. Gentlemen, any final thoughts?
No, just thanks for everybody for listening, and just if you start doing it, start using it, and send us you're going to come up with questions, and you can send them our way, and we'll try to help you out the best we can.
Yeah,
Just so everyone knows, I did put in the chat feature the link to the MyEfficientVineyard website. Sorry about that, Nick.
No, you're great. I was just going to just mention that these platforms are kind of early in their blank canvases. So if there's a feature that you're just like burning to have or to try, we want to know what those, what those features would be.
Great. All right. Well, thanks everyone again for joining us today. I hope you all have a good day.
Thank you.
Terry and Nick.